Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called HDR Thermos by Blobs. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have yin-yang, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected. Now, what does that mean? Well, what's a valid yin-yang shading? This is a valid yin-yang shading. And what does it mean that all the shaded cells, and no 2x2 areas fully shaded or unshaded? I forgot about that part. That's also important. So you can't have a 2x2 area that's all fully shaded or all fully unshaded. What is the orthogonally connected shaded cell? What does that mean? It means you can go from any cell in the shaded region to any other cell in the shaded region by going through edges and just staying within the shaded region, right? So to get to here, you just go along here on edges, right? This is not a valid shaded cell region or yin-yang shading because if you try to go, let's try to go, this. This is not orthogonally connected to the rest of the shaded region just by going through edges. You have to either go through unshaded region, or you have to go through a corner to connect to the rest of the shaded cells. This would not be a valid yin-yang because we have a 2x2 area, which is all unshaded. And that's an example of how yin-yang works. We have also sight lines, where digits in caged cells indicate how many cells of the same color, that is shaded or unshaded, are seen orthogonally from that position, including itself. The other colors block vision. The other color blocks vision. So digits in a shaded cell, so for the example, this would be including itself. It sees itself, it sees these 4 cells, it sees these 3 cells. It would not see any of these cells in column 5 because it's blocked by that unshaded cell. So this would have to be 8 if that were the case. Same with this one. This would also have to be 8 because it sees itself, it sees all of these digits, and it would not see any digit in its column because it's blocked by that cell. So this is 8. This would also be 8. Obviously, that doesn't work with normal Sudokus, but that's important for caged cells. And then we have HDR thermos, where the values on thermometers must increase from the bulb end. For the purpose of evaluating thermometers, digits in shaded cells have negative value, while digits in unshaded cells have positive value. So, actually, this thermo does not work at all because you would have to go negative to positive back to negative, and negative values are less than positive values. So that would not work for this thermometer. But say we had something like 9, 6, 3, 1, 4. This is a valid thermometer if the shading is correct, because you would have a value of -9 at the bulb, -6 here, so that's greater than -9, -3 here, which is greater than -6. You'd have a value of 1 here, which is greater than -3, and you have a value of 4, which is greater than 1. So this is valid as a thermometer if the shading was like this. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is interesting then. Where do we want to start with this yin yang? Uh, huh. Um, well, in yin yang, there's a couple of like deductions that you've rules of thumb. Well, not rules of thumb. Things that we basically figured out about yin yang shading. Once you've changed from one shading to another, you can only change back one other time. So you can't have something along the lines of shaded here, unshaded here, shaded here, and then unshaded. Because how do you connect the shaded and the unshaded regions orthogonally? You can't. Because if this connects this way, this will change the unshaded region into multiple unshaded regions, and that's not allowed. Same if you try to connect orthogonally from the unshaded regions. That would necessarily force the shaded regions to essentially not be two separate regions, which is not allowed. We also know if you have a shading diagonally of one color and then another color, you cannot have a shading of the other color in the other diagonal. And it's similar, like how do you connect these regions? You can't without essentially forcing the other shading to have two separated sections. So that's never going to work either. Okay, we don't know much about thermometers here because they could be negative or positive. Um, hmm. Digits in cages are always going to be 2 through 9. And the reason why you know that is all shaded cells are orthogonally connected. So you'll always see yourself and your connection to the rest of the shaded cells, right? You can't have a shaded cell here and it be surrounded by 3 unshaded cells because then it cannot be orthogonally connected to the rest of the shaded cells. So you'll always have one at least connected here. That means the cages similar for unshaded cells. So that means all the cage numbers are 2 through 9. We know that for certain. So where are the ones is kind of the question, right? Oh, you know, in a 2x2 area, you cannot have all of them the same shading. Therefore, at least one of them is going to be shaded and one of them is going to be unshaded. Well, these digits are always going to be, this is always going to be the lowest value digit. This is always going to be the highest value digit. Since you know you have one shaded at least and one unshaded at least in this 2x2 area, you know this must be shaded and a negative value. And this must be unshaded and a positive value. So this has to be the highest one. We don't know specifically there. Same with this 2x2 area. So this is unshaded. This has to be shaded here. Sorry, this is shaded. This is unshaded. So we know this is blue. This is green. Do we have another 2x2 area where that's the case? No. So these are all the 2x2 areas. This has to be green because it must be greater than that. This must be blue because it has to be less than this digit. So this cannot be 9. If this were 9, it would be... This has to be greater than 2 through 8 in value, so this is 3 through 9. We don't know what this is, so it could be negative. Okay, this can never be 9, period. It's in between. Can it be 8? No. Because if it were 9 or 8 here, the problem is it has 2 digits smaller than it, or 2 values smaller than it, and 2 values larger than it. Therefore, it can never be, it has to be 2 through 7 here. So this is also 1 through 7. This also can't be 8 or 9 for the same reasoning. You always have 2 values smaller and 2 values larger. Same with this one. So this is 1 through 7. This is 1 through 7. Okay, where is the 1 then in row 5? It has to be one of these 3 cells. Because none of these can be 1 because of how sightlines work, and this is greater than that digit, and it's positive. These are both positive. Let's see. We do not have another 2x2 area. That was very helpful. This 2x2 area has to be shaded and unshaded, right? But since it's a corner, these cannot be the same shading. If this is all shaded and this is unshaded, this is not connected to the rest of the region. Same with it. Same if they are all unshaded. If these are all unshaded, this is shaded. The shaded is not connected to the rest of the shaded region. So we know we have one of each here too. So this must be shaded and this must be unshaded here because of how that works. Same with, well, this one could be all the same shading here. This is also works the same way, right? We know if all of these were the same shading, this would not connect to the rest of the region. So there must be different shading here, which means there must be a blue and a green here. This must be blue and this must be green. Well, this all must be blue then, because again, like I told you before, if it tried to switch to green here, the problem is you'd already have too many switches, right? This green would have to connect to the rest of the greens orthogonally, and that would necessarily break the blues up. So this has to be all blue then. So we know this is all blue. This digit could be an 8. So this is also 1 through 7. This is also 1 through 7. This cannot be 8 or 9. This is 2 through 7 then. This necessarily sees 8 cells at least. It's 8 or 9 here. It sees 8 blue cells here. This sees at least 2. These all must be green because these have to be greater than this, and this is a green. So this is at least 2 through 8. This is 3 through 9. We have 3 greens in this 2x2 area, therefore this cannot be green. This is blue. What else do we have? This 2x2 area, they could all be the same shading. Same with this. Same with this. This could be 3 shadings all being the same. This has to be blue because it must be less than that. So this is up to 8, but it could be 1 through 8 here. We actually don't have very much information there. This is a 2x2 area with 3 blues, so this is green. This is a 2x2 area with 3 greens, so this must be blue. This is a diagonal blue. This cannot be a diagonal green, therefore this is blue. This sees... Okay, so this is greater than this, so this cannot be 2. This is greater than this, it cannot be 3. This is less than this, so this must be... It could be 1 through 8. This sees at least 2. That's fine. This then sees at least 3. That's fine. This sees at most 2 this way, and then 3, 4, 5, 6, 7, 8. So this cannot be 9. If this were blue, this would have to be blue. And then this green would be blocked off from the rest of the green regions. So this cannot be blue. This is green. So this is less than this. So this is 1 through 8. This is 2 through 9. This is less than this, but so this is 2 through 9. It cannot be 1. Okay. This cannot be a 9, because if it were 9, the problem is it's less than another digit and it's greater than 3 other digits. So it's never going to be a 9. Can't be at the extremes. Same with this. This can't be 9 either. Okay. If this is green, this is either green or blue. If this is blue, this has to be 2. It sees only 2 cells because it's blocked by here, here, and here. If this is green, though, it would see 1, 2, 3, 4, 5. So this is either 2 or 5. This sees... Well, we don't know. So this is pretty... You could extend here. We know this is specifically 2 or 5, though. Okay. Let's see. Blue, blue. What else do we know? Well, we know the shading changes somewhere here. We're not sure where, though. This cannot be unshaded. If this was unshaded, this 2x2 area would have to basically force this to be shaded, but then again, you'd have a green area and a blue area, which already changes twice, which is not allowed. So this cannot be... This cannot be green. If this is green, that forces this to be blue here because of the 2x2 area, which is all green. But then you've already swapped from blue to green, back to blue, and then you'd have to swap again to green. And to connect orthogonally, they would necessarily force the blue region or the green region to have 2 regions. So this cannot be green. This is blue. This is blue. We don't know about this. Hmm. Um, Sightline. So this is 9. It sees all 9 blue cells. This cannot be 9. This can't be 8. So this must be greater than, this must be less than that. This can't be 9 either. This can't be 9. Hmm. So this is negative. This has to be 2 through 8 because it has to be smaller than this. So it's smaller than -1, which would make -2. Therefore, this is not -2. This could be -3, though. This sees 9 digits. That's fine. 9 blue shaded cells. What else do we have? These, well, they could be different shadings, so that's not necessarily the case. Never mind. I was going to say that these have to be different, sees different amounts, but that's not true. Hmm. Hmm. Can this ever be the same shading? Maybe? No, it cannot be. If this were all the same shading, whether it's blue or green, these would then have to be green and green, but you'd have blue essentially be broken up into 2 regions at least. Say this was green, though. Then again, you'd have blue and blue. But again, the green would be broken up into 2 regions, or the blue or the green would, right? So these have to be different shadings. 1, 2, 3, 4, 5. So this must be green, and this must be blue at least. So since this is blue, this must continue blue all the way here. We don't know about green. This is, so this will see 9. 9 blue. So this is at most negative, at least -8. This is at most -7. But it could be 2 through 8, 1 through 7 here. These are negative. So this is -8, -7 at most. So this is -1, -2 at max. Sorry, -8 at minimum. -2 at max. 9 cannot be any of these because of the 9 in the row. Okay. Can all of these, can these be green now? Possibly. Can all of these be a single color? Maybe. Yeah. That's a maybe. Um. Hmm. What about this? Maybe. Yeah, that's also maybe. Uh, One of these has to be green because we have 2 blues here. Therefore, if one of them, at least one of them is green, this has to be green because it's larger than that one. So this is always green. This is always green. This blue must connect then to the rest of the blues. So this is blue here. This sees specifically two. It only sees these two. It can't see it past these greens. So 2 cannot be here. This can't be 2. This sees at least 2. This sees at least 2. Sorry. This sees at least 3. So it must be blue here because it sees only 2 this way. It must see another one. This must see another one somewhere, but we don't know which. We have a 2 by 2 area that's all blue, so this must be green. That means this must be green because, again, you can't have the diagonals of different colors be there. This sees at least 4. So this is at least 4 greens. One of these must be blue, at least. And it cannot be that one because, again, like this would be green, this would be blue, but then you'd have the blue and green areas separated on the edges twice, more than twice. So this has to be blue. This could still be blue here. This sees at most 1, 2, 3, 4, 5, 6, 7, 8. That's fine. This sees at most 8. This can't be 2 because of the 2 in the column. This can't be 2. This can't be 2. So this cannot be 9. It sees at least 4 right now, so this can't be 2 or 3. It must be less than this digit, so this is 5 through 9. Hmm. This digit is larger than this, and it cannot be 3 then, because this, if this were 3, this would be 4 through 8, and it would be necessarily larger. This can't be 9, so this can't be 8 here. This can't be 7, because it's continually decreasing from there. This could be any digit from 1 through 8. We don't know. This 9 eliminates 9 in the rest of column 2. So this is less than that. It must be 8. This is, sorry, this is greater than that. So it must be not 8. This can't be negative 7 because it's greater than that. This is positive. This is positive. So where is the 9 in column 3? It must be one of these two digits. We don't know which. Hmm. Interesting. This cannot be blue. If this is blue, it would see 9 blues here. And we know it can't be negative 9. So this can't be blue. This is green. We don't know how many digits it sees there. This could still be negative 9. That's possible. As a blue. So this is greater than that digit. So it's 3 through 9 here. Hmm. Hmm. Um, can this ever actually see 9? 1, 2, 3, 4, 5, 6, 7, 8. No. So this is 4 through 8 here. Okay, this cannot be all blue this way. If it's all blue this way, the greens are divided then into 2 segments. So this cannot be 8. Could be blue all the way to here. That's possible. Unlikely, but possible. Um, hmm. This cannot. This is 1, 3, 4, 5, 6, 7, 8. Hmm. That's not helpful. This digit is less than that, so it must be not 8, because this can no longer be 9. Can this all be the same shading? And the answer to that is no. If it's all, well, no. If it's all blue, the greens would be cut into 2 regions. If it's all green, there would have to be blue here, and that would be not orthogonally connected to the rest of the blue regions. Therefore, this must be blue, and this must be green, because again, you can't. Therefore, we have a 2 by 2 area, which is all green, so this must be blue. This must connect to the rest of the blues on the grid, and it can't be have a green here. This sees at least 5. Oops. So this can't be 2, 3, or 4. Actually, it sees at least 6. So this is 6, 7, 8, 9. This cell sees 4 guaranteed. So this is 4, which means this cannot be 4. So this has to be greater than that, so it's 5. This then must see at least 5. We don't know how many. These can't be 4. This can't be 4. This sees 2 at minimum. Could be 3, 4, 5. So this can't be 6, 7, 8, 9. 4 cannot be any of these. 4 cannot be here. One of these two must be green. And both of them could be green, but that forces this to necessarily be green. You can't have cross diagonals of the 2 of the same color with the other 2 of the color. So this is green. Well, it had to be green anyways. This sees 2 then. It sees only these 2. Can't see any of these. This can't be 2 here. No 2 here. This is greater than that, so this must be at least 5. This is greater than that, so it's at least 6. It's 6 through 9. This is 5 through 8, and this is 3, 5, 6, or 7. This can't be 2, obviously. If this were green, the problem is this has to be less than this one, But this can only see the same number in the column and just one here. Well, if this is green, it must force all of these to be green. So this would see 4 green here and whatever is in the column here. So it would necessarily have to be greater than that digit. So this cannot be green. This must be blue. So this sees at least... Okay, and this must be as a value less than this. Well, okay, it will always be less than this. It sees only green. It sees however many are in the column. So this is -6 or 7 or 8. This is -7, 8, or 9. So this is blue. Hmm. Okay. This sees 2. This sees at least 7. This sees at least 6. What else do we have? This must see at least 3. We don't know where it is. Can this ever only see 2? No. If this sees 2, the problem is these would be blue and this would be blue, so this green would be a separate region from the rest of the green. So it cannot be 2. It can't be 3 either. If this is 3, this is both blue, and the green, again, is not in a separate region. So this is at least 4. That means this is greater than it. So it sees at least 4. It could see 4. That's possible. Can this see 9? No. If this is 9, it would have to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Or, and this would be a 2x2 area that's all blue. Wait, it could be green. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the blue goes around here. So this still could actually be 9. We don't know if it's green or blue. That's essentially the issue. Okay. 2 cannot be here in the column and in column 5. If this were 7, that would force this to be 8 and 9, and then this cell would not have a possibility in that column, so this can't be 7. If this were 6, these digits would be 7, 8, or 9, and these two digits would have to be 7, 8, or 9. And again, we'd have an impossibility for these 5 cells. So this cannot be 6 here. If it's 5, that is possible, actually. So we know in box 2, the 1 has to be one of these 2 digits. Because these digits specifically cannot be 1. And this must be greater than this. So 1 is one of these. 1 cannot be here. 1's one of these 3. 1 could be any of these 4. Okay. This sees 3 or 5. If it's 3, it could be here or it could be here. If it's 5, that means these are guaranteed. Does that tell us anything? Not particularly. Okay. Can these be the same shading? I think so still, yeah. So if they're the same shading, it would have to go like this. Possibly. This is 1 through 8. If this is 9, that means all of these would be blue. This would be 8. Ah, if this is 9 and this is 8, the problem is all of these would be shaded. So this would see guaranteed 8, but it can't be 8 or 9. So that doesn't work. So this cannot be 9 and 8. Maybe 8 and 7 has the same problem. If this is 8 and this is 7, all of these would be shaded. This would have to be, I guess it could be 9? But then if it's 9 in blue, that would be 1, 2, 3, 4, 5, 6, 7. This would not be blue, that would be green. So this would have to see shading that way, and this 2x2 area then would be all shaded, which is not allowed. So this cannot be shaded. This has to be unshaded, which forces this to be unshaded too. This is unshaded. This then sees 7. So this is 7, this is 6. That means 6 and 7 cannot be in the rest of the box and the row. So this can't be 6, this can't be 6 or 7. No 6, 7, no 6, 7. This is less than that, that's fine. This could still see 9. That's possible. This sees at least 4. This sees at least 4. This sees at least 3. We have a 2x2 area, which is all green, so this must be blue. Therefore, this sees exactly 4. So this is 4. This cannot see more than... This has to see at least 5. So this is green. But it sees at most 8. So 1, 2, 3, 4. Okay, so this can't be 5. This is greater than this. This can't be 4. This can't be 4. This can't be 4. This sees 1, 2, 3, 4, 5, 6, 7, 8 at most. So these are all blue. Because it could be less, could be 5 here. And then these are all blue. Or it could be 8, and these are all green. So these are all the same shading. That's interesting. Right? It sees 5, it would see just these 5. If it sees 8, it sees 1, 2, 3, 4, 5, 6, 7, 8. So these are all shaded or unshaded. We're not sure which. This sees at least 3. This sees 3 or it sees 5. This can't be 6. This can't be 4. So at least one of these must be green. Otherwise, if they're both blue, it doesn't work out. So since at least one of them's green, this is guaranteed to be green because it must be greater than that cell. So if this were green, then obviously that's green. If this is green, then obviously the green's here. So either way, this is green. This sees at most 1, 2, 3, 4, 5, 6 blues. So this cannot be... This is 3, 5, or 6. This is less than that. Or sorry, greater than that. So this must be 1 through 5. Cannot be 2 or 4 because of the 2, 4 pair. 2, 4 in the row. 4 must be one of these 3 digits. Rest of box 2 is 1, 3, 5, 8, 9. Okay. That doesn't tell us much. Okay, if this is blue, the problem with this being blue is Okay. If this is blue, this has to be green. Which means... So if this is blue, this has to be green, which forces this to be green. This cannot be all blue. Actually, it could be all blue. Never mind. It just has to connect. So that's possible. Okay. That would mean this is 5, so this would have to be green. This would be blue. So this would have to be green here. This would be green here. This would be blue. This would have to be blue. Aha. And that's why, yeah, this could not be all blue. Because if all of this were, it can't be blue, all of these, because this 2x2 area would be all blue. So if we tried to make all of this blue, this has to be the blue, and this would be green, and we'd have a cross here. So that doesn't work. So even if this is blue, one of these must be green then, which means both of them have to be green. Obviously, if this is green, then the rest of this has to be green. So we know this is always green. So this is green. That makes this 8. This is 8, which forces this to be 9. This cannot be 8 here. That sees all green, so the rest of this must be green. Because of this 2x2 area, then this is all green. This has to be blue. Same with this 2x2 area. This must be blue. We don't know if this is blue or green. If it's blue, it must connect out this way, which is interesting. If it's green, it has to connect out. Okay, so if this is blue, this is green, so this blue must connect out here. So this is blue. If this is green, okay, so this is greater than this. This cannot be 1. This can't be 1 in general over here. So this has to be at least 2, which means this can't be 2. This is less. This is at least 4 through 8, 5 through 9, 2 through 6 here. And this could be a negative number here. So if this is blue, this is green, so the blue must come out and connect to the rest of the blues this way. So this is blue. If this is green, this blue must connect out this way, so this is always blue. Okay. This is green. These are green. This sees at most 1, 2, 3, 4, 5 blues. So this cannot be, it can't be 4, so it's 3 or 5 here. Huh. This can't be 4 because of the 4 in the column. This can't be 8, so this has to be greater than that, so it can't be negative 7. What else do we have? This sees 1, 2, 3, 4, 5, 6, 7, 8, 9. It's possible. It sees at least 3, though, so this can't be 2. One of these must be green. One of them is blue. We're not sure which is which, though. If this sees 5, it sees all of these. If this is 5, it would block this blue region in from the rest of the blue region. So this cannot be 5. This is 3. So this can't be 3, this can't be 3, this can't be 3, and these can't be 3. So since this can't be negative 3, this can't be negative 3, 4, or 5. So this is negative 6 through 8 here. the rest of row... So where is the 8 in row 2? Can't be here because of the 8 in the box. Can't be either of these because this must be greater than -8, and this must be less than 8. So this has to be an 8 here, which means this cannot be 8. The rest of row 2 is 1, 5, 6, or 7. So that's also still possible here. This is 3, so this cannot be green, so this is blue. Well, if this were green and this were blue, the green would not be orthogonally connected to the rest of the green. So this must be blue, which makes this a green. This sees specifically 2. So this is 2, which means this can't be 2. This is greater than 2. This is greater than that. This must be greater than that. This must be greater than that. So 2's here, which means this can't be 2. This is 5. It sees then all of these greens. So this must be greater than 5. It's 6 or 7. This must be greater than 6 or 7. It's 7 or 8. So this sees 6 or it sees 7 here. These can't be 5, obviously. This can't be 5. This can't be 5 or 2. This can't be 5. We have a 6, 7, 6, 7 pair. This can't be 7 because it's less than this. Sorry, it's greater than this digit, which is -6 or -7. We have a 6, 7 pair in column 2, which eliminates 6 and 7 in the rest of the column. This can't be 6 or 7 or 5. This is less than that, so it can't be 4, 5, or 6. So we have 1, 3, 3, 4, 1, 2, 3. This must be also 1, 2, 3, or 4. This can't be 5. This can't be 2. These 2x2 areas all blue, so this must be a green here. Cannot be 3 here, though, because this sees 3. These 2x2, this green diagonal is green. This can't be, this is blue, so this can't be blue here. This must be green. This cannot be 3, -3. This sees, could see all of these still. This 2 eliminates 2 here. Where is the 2 in box 3? It has to be one of these two. Where is the 2 in row 1? It must be one of these two. Okay. This sees only 3. So this must be -3. -1 is the only negative digit that's higher than it, so this must be -1. This can't be 1 or 3. This is 5. That means this can't be 5, so this can't be 6. This can't be 1, 3, or 5. This can't be 3 or 5. This digit must be greater than that, so it must be greater than 4. It sees at least 6, so it must actually see 9. So this sees 9, and therefore this is all green. This can't be 1, 3, or 5. It's 4 or 6. The remaining digits in. So where's the 1 in row 5? It has to be here. This is 4, 6, 7, or 8 remaining in column 8. This sees 9. This 2x2 area is all green, so this must be blue. This blue has to connect out, so this is blue. It must connect to here, so that's blue. Orthogonally. This is all connected now, so we don't have to worry about the greens necessarily. This sees either 1 or 2. One cannot be here, 1 cannot be here. We have a 5, 6, 7 triplet in box 1, which eliminates 5, 6, and 7 from the rest of the box. 5 can't be here either, so this is 1 or 9. 5 has to be one of these 3. This can't be 5. This is 6 or 7. So 5 is one of these two. We also have 1 through, okay. 1 through 4 and 9 in the rest of box 1. And this can't be 2. This can't be 2. 1, 2, 3, 4, 9. This can't be 9. This can't be 9. This can't be 2 or 3 because of the 2. One of these has to be 2. So this is 2, 6, or 7 here. This is 2, 6, or 7. So 3 is one of these 3 here. Okay. 5. 2, 6, 7. 2, 6, 7. This is less than -4 or -6. So it cannot be 2, 3, or 4. It's -5 through 7 here. This is 9. This sees 7 digits. So this is 7. This is 8. None of these can be 8 then. This can't be -7. So this can't be -6 because there's no digit smaller than it. So this is -4. This is -5 or 6. This can't be 4. We have a 6, 7 pair in box 6, which eliminates 6. Actually, this 7 eliminates 7 here, so it's 6. This can't be 6 or 7, so it's 2, which makes this 7. This 6 eliminates 6 here, so this is 5. This can't be 5 or 6, so it's 7, which makes that 6. This can't be 7, obviously. This 6, 7 pair in box 6 eliminates 6 and 7 in the rest of the box. This can't be 6 or 7. This is 3 or 4 with 4 or 5. This sees only 3 digits, so this is 3. This could be 4. I can see 1, 2, 3, 4, 5, 6 at most. So this is 4, 5, or 6. This 8 eliminates 8 here. The 3 eliminates 3 here, so this is 4. That means this can't be 4. This can't be 4. It's greater than 4. This can't be 7. This can't be 7. This can't be 7. This sees 8. And it must see exactly 8. So this is blue. This must be 9 to be greater than the 8. This can't be 8. It's 5 or 6. This can't be 4 because it sees a 4 in its row. So this is 5 or 6. It must see then the blue. Well, interesting. If it sees 6 here, if this is green, the problem is it would only see 2 digits, and we already have a 2 in the column, so this can't be green. This is blue, which forces this to be green. Therefore, this sees 7, and this is 7 and 8. We already knew that. That's 6. This is 7. This sees 3 digits that are the same shading, so this is 3. This sees 2, so this is a 2. This can't be 3, 7, or 8. This sees specifically 4. So this is 4. This sees specifically 6. This sees 1, 2, 3, 4, 5, 6, 7, 8. So this is 8, which means this can't be 8. This is 9. This can't be 8 or 9. So this is 1. This can't be 1, 8, or 9. So it's 5, which makes this 8. This can no longer be 9. Where is the 9 in box 1? It has to be here. So this is 9. This has to be a 2, 3 pair. This can't be 6. This can't be 4. Cannot be 7. It's a 1, 3, 5 triplet. 3 cannot be here. So this is 1 or 5. This sees 4 blue digits. So this is 4. This sees 1, 2, 3, 4, 5, 6 blue digits. So this is 6. This cannot be 6, 7, or 8, or 4. It's 1 or 3. The remaining digits in box 4 is 1, 2, and 3. Well, we have a 1, 2, 3 triplet now in column 1, which eliminates 1, 2, 3 in the rest of the column. So this can't be 1. This is 4, which makes this a 1. This 6 eliminates 6 here, so this is 5. That leaves this digit as a 3. So this can't be 3 here. This is 1, which means this can't be 1. We have 6, 7, and 9, or 6, 7, and 8 remaining in column 1. This can't be 7 or 8, so this is 6. This can't be 6 or 8 here because of those 6 or 8 in a row, so this is 7. That makes this 8. This cannot be 3, this cannot be 8, this cannot be 1 or 5, so this is 3. This can't be 2 because of the, or 4 because of the 2 or 4 in the column. Sorry, the 2 in the column and the 4 in the row. Remaining digits in column 4 are 2, 6, and 7. 2 cannot be either of these, so 2 must be here. That leaves 6 and 7 remaining. And this can't be 6 because of the 6 in the row, so this is 7, which makes that 6. Remaining digits in column 7 are 5, 8, and 9. This can't be 5 or 8 because of the 5 or 8 in the row, so this is 9, which makes this 8. That makes this 5. This can't be 5 anymore. This is 7. This can't be 5. This is 1. This can't be 5. It's 6. We have a 1-2 pair left in box 9. This can't be 2 because of the 2 in the row, so this is 1. This is 2. This can't be 4 anymore because of the 4 in the row, so this is 5. This can't be 7, so this is 6, which makes that 7. This 5. This 1 eliminates 1 here, so that's 5. This is 3 or 4. It cannot be 4 because of the 4 in the row, so this is 3, which makes this 2, which makes that 3, which makes that 2. This can't be 2 or 3, so this is 1, which makes that 3, which makes this 4. That makes this a 1, and this is a 9. Actually, we're missing 2 digits more, 4 and 5. This has to be 5, and that's a 4. And that's a solution. Yeah, I really like this negative and positive thermos. The shapes of the thermos force different constraints, right? So that was pretty cool. Obviously you have -6, -5, -3, 7, 8. That's fine. -7, -6, 3, 8, 9. That's fine. -3, -1, 5, 8, 9. That's fine. -9 to -3, 5, 7, 8 is fine. -2 or 2, 4, 5, 7, 8 is good. -7 to 1 to 3. Sorry, -7 to -1 to 3, 8, 9. That's fine. -9 to -6 to 1, 4, 5. That's fine. -6 to -4 to 7, 8, 9. That's fine. This 4 sees 4 green cells. This 2 sees 2 blue cells. This 7 sees 7 blue cells. This 6 sees 6 blue cells. This 4 sees 4 green. This 8 sees 8 green. This 3 sees 3 green. This 2, where did that? This 3 blue sees 3 blue cells. 5 sees 5 green. 6 sees 6 blue. 8 sees 1, 2, 3, 4, 5, 6, 7, 8 blues. Green sees 2 blues. This sees 9 blues here. This sees 7 greens. 5, 6, 7. This sees 3 greens, 2 greens, 4 blues, 4 blues, 2 blues, 6 blues, 3 blues, 8 greens, so 7 plus 8. This is 7 greens, 9 greens, and 9 blues. So everything works out. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.